All right, welcome to this explainer. Let's just dive right in because we have a lot of ground to cover. For decades, we've always thought of mathematics as the ultimate frontier of human logic, right? Like a purely human endeavor. But recently, a monumental shift has happened. Today, we're looking at how artificial intelligence went from just solving basic known puzzles to fundamentally altering the landscape of high-level, research-grade mathematics. And listen, this isn't just about giving us faster calculators. We're talking about machines actively participating in mathematical discovery. So, the summer of 2025, that was the definitive tipping point. In July of that year, AI models did something that absolutely shocked mathematicians. They solved 5 out of 6 problems at the International Mathematical Olympiad. Now, if you're not familiar, this is a grueling test meant for literally the brightest high school students in the world. And sure, Olympiad problems have known answers, but seeing AI master them so rapidly, that made the mathematical community sit up and realize things were changing way, way faster than anyone anticipated. And then, by early 2026, that shock turned into straight-up awe during a challenge called First Proof. Mathematicians gave AI models 10 graduate-level research questions. These were problems carefully chosen so they wouldn't be in the AI's training data, and the models solved over half of them. As mathematician Daniel Litt realized, and I love this quote, "It's very likely that this technology is bigger than the computer." Passing this graduate-level threshold meant AI was now dealing with open, unsolved questions. That is a historic, paradigm-shifting moment for the entire field of math. But what's truly staggering here is the blazing speed of this revolution. Just look at how compressed this timeline is. In less than a year, we went from AI solving Olympiad puzzles in the summer of 2025 to the creation of advanced systems like AlphaEvolve in the fall, to conquering graduate-level challenges in early 2026, and finally to actually solving an 80-year-old open theorem by May 2026. I mean, we are looking at an unprecedented velocity of discovery. Okay, moving into section 1, the alien collaborator, working with the machine. We really need to look at how this AI actually works in practice, because it's important to understand that AI right now is not some infallible, all-knowing oracle that just spits out perfect answers. Not at all. Instead, mathematicians describe it as a wildly fast, incredibly creative, but honestly, sometimes error-prone brainstorming partner. It's kind of like having an alien colleague sitting next to you at your desk. So the crucial point to grasp here is the massive contrast in methods. Traditional math is an agonizingly slow, deeply deliberate process. Human mathematicians spend weeks, maybe months, carefully navigating literature and building step-by-step logic. AI-assisted math? That is all about high-velocity brute force. These models just throw millions of possibilities at the wall at scale to see what sticks. They use trial and error, they unearth bizarre hypercubes, and they can basically do in a single day what would take a human researcher months to accomplish. Now here's a quirky reality discovered by Javier Gomez Serrano and his team while they were working with a system called AlphaEvolve. They found that the AI actually performed better when it was prompted with positive encouragement. Seriously, literally typing things like, "You can do this," into the prompt improved the mathematical output. It's this fascinating, almost eerie little detail that really reveals just how strange our new mathematical collaborators are. And as an alien collaborator, the AI will do things like talk to itself and invent these bizarre strategies that it actually calls Crazy Ivan maneuvers. It'll make weird, incredibly basic errors that a college freshman wouldn't even make. But then, in the exact same breath, it will uncover profoundly subtle and original mathematical concepts. So what does this mean for us? Well, the human mathematician's role shifts. We no longer have to generate every single idea. Instead, we become the essential verifier of the AI's wild, chaotic output. All right, section 2, solving the unsolvable, real-world triumphs. Let's step away from the theory of how they work together for a second and look at some concrete case studies. I want to show you where AI has successfully tackled problems that have completely stumped brilliant human minds for decades. Take the work of mathematician Ernest Ryu. He used ChatGPT to prove the Nesterov conjecture, which is a problem that had sat unsolved for 42 years. It deals with something called gradient descent, a crucial optimization technique used to train machine learning models. To put it simply, gradient descent is the invisible math powering the apps on your phone right now. Everything from recognizing your face to curating your social media feed. The whole goal is to find the minimum of a complex function. Think of it like trying to find the very bottom of a mathematical hill, in the dark. You find the downhill slope, You take a step downward, and you adjust your speed based on your past path so you don't overshoot it. By playing the role of verifier, Ryu used ChatGPT to finally prove that this specific method perfectly converges on the lowest point. In another massive victory, a team of mathematicians used AlphaEvolve to study something called a Bruhat interval. Basically, a Bruhat interval is the set of all different permutations, or shuffles, that lie between two specific arrangements of items. And by unleashing AI onto these intervals, the human team realized the AI had actually uncovered a massive, higher-dimensional hypercube structure. This incredibly beautiful structure had literally been hiding in plain sight in the mathematics for 50 years, and it went completely unnoticed by humans. Now, you might be wondering, why couldn't humans see it? Well, to understand the impossible scale these mathematicians are dealing with, consider a permutation group of just 60 items, say a deck of 60 cards. The number of possible arrangements for those 60 items is roughly equal to the number of atoms in the observable universe. Human brains simply cannot visualize structures at that incomprehensible scale. It's impossible. But the AI, it could explore these treacherous waters endlessly without getting overwhelmed. And that sets us up perfectly for perhaps the most mind-blowing breakthrough from May 2026. This centers around a famous geometry puzzle called the unit distance problem. The premise is deceptively simple. If you draw a certain number of dots on a page, what is the absolute maximum number of pairs of dots you can arrange so that they are exactly 1 inch apart? This specific problem went completely unsolved for 80 years. The legendary mathematician Paul Erdos set a record way back in 1946 using a tightly packed grid, and he claimed no one could do better. Everyone believed him, sure, but no one could definitively prove it. Well, enter an OpenAI model. Completely without any human help, it generated hundreds of pages of logic, actually beating Erdos's record. And the way it did it? It constructed a bizarre, higher-dimensional lattice and then mathematically flattened it into a 2D shadow. I mean, it was a completely counterintuitive approach that no human had ever even attempted. Which brings us to Section 3, the dark side of AI math, an ocean of slop. As you can probably imagine, an industry-shaking disruption of this magnitude isn't without some serious conflict. It has sparked incredibly real, deep anxieties within the academic mathematics community, and we need to understand exactly why. So the absolutely crucial point here is quality control, because AI models can hallucinate math that looks completely correct at first glance. Academic journals are currently being flooded with AI-generated nonsense. Mathematician Joel David Hampkins perfectly captured this frustration, saying he is despairing of this ocean of slop that is overwhelming our journal systems. To combat this, the community is desperately pushing for auto-formulation, which is basically a system where computers can automatically check and verify the underlying logic of a proof before it ever sees the light of day in a publication. But beyond the journals, there are deep systemic fears. For one, we're kind of looking at the death of traditional math homework because, well, AI can just solve it instantly. Professors fear this is going to seriously stunt student development. If AI does all the heavy lifting, how do we train the mental muscles of the next generation of human researchers? Furthermore, as mathematician Melanie Matchett Wood warned, these models routinely fail to credit existing human literature. They're essentially plagiarizing past ideas and presenting them as their own. It's a massive professional dilemma that the entire field is actively trying to navigate right now. Finally, Section 4, Art versus Science, the future of human intellect. As we embrace these ridiculously powerful tools, we are forced to ask a fairly profound philosophical question. Because mathematics isn't just about finding the right answer, is it? It's about the elegance of how you get there. So will AI strip the beauty and artistry out of this deeply human craft? To reassure us a bit, mathematician Terence Tao offers a really brilliant analogy. He compares current AI models to jumping robots. Yes, they can brilliantly parkour their way to the top of a 6-foot wall to solve tedious, isolated tasks. But human mathematicians, we are the long-term planners. We are the ones plotting the massive, multi-year expedition to scale the Mount Everests of math. The AI can absolutely help us jump over the crevasses along the way, but humans are still entirely required to set the destination and carefully plan the route. So, as we wrap up this explainer, I want to leave you with a thought inspired by Fields medalist Akshay Venkatesh. Mathematics is ultimately shaped by human values. It is as much an art form as it is a strict science. We are clearly entering an era where AI might actually prove to be better at calculating than we are. But if mathematics is an art, What happens when a machine holds the brush? It's a fascinating, maybe slightly terrifying question that will absolutely define the future of human intellect. Thank you so much for joining me, and keep exploring.